Yeah, hello friends. Today we are going to discuss about large language models. Large language models are a powerful artificial intelligence models that can understand user input as a prompt and generate human-like text, images, video, audio, and code as well. Actually, the large language models are a subset of deep learning. This is how it looks like. Okay. So, in this video, we are going to discuss about define a large language models and various kinds of large language models available and prompt design versus prompt engineering and how large language models works and brief exploration on the transformer architecture. Okay. So before diving into the large language models, we'll just have a look into the available large language models. So the website called llmmodels.org, you will find the major and available large language models in this. So we have a open source and paid large language models. You can filter by applying this. Okay. So this is a platform you can explore more large language models available, and by clicking a show more all, you will find a lot of large language models currently available. And also there is another website called Hugging Face. This is also one of the uh, largest large language model platform. This is a machine learning and data science platform. It's also act as a community, and you will able to build and deploy your own machine learning models, and also you can provide a demo to your clients in a real-time applications. Okay. And coming to this, so we are already having some knowledge on Google Gemini, OpenAI's ChatGPT, that X Grok and Midjourney. This is one of the largest image generation LLM model, and Microsoft's Copilot, Coher, and this NVIDIA's Megatron. So these are all the large language models currently available, and also these are a multi-modal large language models. Okay, yeah. Coming back to the large language models. So large language models are trained on a massive amount of data, which allows them to learn patterns and the relationship between the words and sentences. This data can be include books, articles, code, and other text and image-based informations. Okay, so large language models and generative AI are intersect, and both are part of a deep learning. Okay, so you will just need to know about the relationship between LLM, deep learning, and generative AI. This deep learning is a type of machine learning that uses artificial neural networks, allowing them to process more complex patterns than machine learning models to mimic the human inputs or languages. Okay. And generative AI is a type of artificial intelligence technology that can produce various types of content, including text, images, audio, and synthetic data by learning patterns from the large language models. I have already created one video on generative AI. You just have a look into that. And coming to this large language models, the large language models are designed and built using a type of artificial neural networks called transformers, which is particularly well suited for sequential data processing. The large language models comes from the use of transformer architecture. In high level, the transformer model consists of a encoders and decoders. Okay, this is how encoder. This part is a encoder level, and this part is a decoder level. In this encoder and decoder level, encoder encodes the input sequence and passes it through the decoders, which learns how to decode the representation for a relevant tasks given by the user. So coming back to the large language models, by analyzing the vast amount of data, the LLMs learn to recognize patterns, understand the context, and generate a coherent and relevant text. And large language models refers to a large and general purpose language models that are pre-trained on a massive data sets and can be fine-tuned for a specific tasks. So, pre-training is a process of training an LLM on a large data sets to solve a general language task, that is called a text generation, question and answering, document summarizing task, and the language translation. It's like a Google Translators. Actually, Google Translator is also a internal large language model. It's already we are already working on that. Okay, and fine tuning. This is one of the key aspect in a large language model. Fine tuning is adjusting a already pre-trained models with a smaller and task-specific data sets to focus on a particular use cases, such as creating chatbots for retail, healthcare, insurance, or generating a financial reports, or script writing, or creating content production to the content production and more. Okay. So actually, we would like to know the various kinds of large language models. There are three types of large language models that are generic language models, instruction tuned large language models, and dialogue tuned large language models. So coming back to this generic language models, these are a foundational large language models pre-trained on a large data of text without any specific task tuning. The primary goal is to predict the next word in a sequence and enabling them to understand the context and generate a desired output. So in this example, we have a GPT-3, BET, RoBET A, and LLMs, Meta's Llama. These are all generic language models. So coming to this example, for example, if you are asked a LLM, the cat sat on the on, so automatically in generic language models predicts that is a the. Okay. So the final completion of the sentence is the cat is sat on the mat. Okay. And coming to the instruction tuned large language models, these instruction tuned large language models are further trained on a specific instruction or tasks. They are designed to follow instructions and complete the tasks as directed by the user. In this example, we have a LLM that is called GPT-4, that is called Generative Pre-trained Transformer 4, and FLAN T5 and other LLMs. Okay. So in this instruction tuned large language models, always it is providing the input with instructions. Like for example, if you take this, summarize the text from a document or uploaded PDF. Here the X is called PDF. Generate a poem in the style of a writer or author. We can provide the author. Author is a instructions. So this is how instruction tuned large language models will help to respond your query or input as a prompt. This dialogue, coming to this dialogue tuned large language models that are specifically fine tuned for a conversational purpose. It's like a chatbot. Okay, they are optimized to maintain a context, generate human-like responses, and engage user in a meaningful dialogues. Best example is ChatGPT, Google Gemini, and Claude. Okay, these are dialogue tuned is a further specialization of instruction tuning and expecting to be context of longer back and forth conversations. That means it holds some previous conversations to prolong the user inputs and respond to the inputs provided by the user. Okay. And coming to this prompt section, actually prompt is a short piece of text that is given to a large language model as an input. and it can be used to control the output of a large language model in the variety of ways. So, and prompt design. Prompt design is a process of creating prompt that will generate the desired output from LLMs like OpenAI's ChatGPT, Google's Gemini, Meta's Llama, Claude, and a Copilot, and more. Prompt design involves understanding the large language model capabilities and its limitations to frame the effective prompts. Prompt engineering is also one of the technique that is a process of crafting a clear and specific instructions for LLM, ensuring they generate a desired output. Prompt engineering includes fine-tuning the prompts and experimenting with a different formats. You can try your own customized inputs and leveraging the advanced techniques like few shot, zero shot, and one shot learning. Okay. So in this, how large language models works. Actually, we are diving deep into some in a short form how large language models works. So initially, the large language models are collecting a mass amount of data that is called books, articles, code, and publicly available websites that are processed in a the raw data is processed in a cleaning and tokenization. Tokenization is a process of splitting the given text in a smaller units. I will give you small explanation in this tokenization. So actually OpenAI provides some token exploration dashboard. So for example, I am just copying this text and pasting it here. How this OpenAI splitting into the small amount of tokens. See this. This is text is split into small pieces that is called tokens. So this is one token. This is another token. This is another token. Totally, we have a 34 tokens. This is how large language models are split your input in a tokens that are converted into vectors, and then LLM will understand following the responses. Okay. Coming back to this. So once the data ignition starts, and the next level, it will pass through the model architecture. Here, the large language models are the major large language models are following the neural networks and the transformer architecture at present. Earlier, we have a LSTM, RNN, and CNN models also there. Currently, most of the large language models are following the neural networks and the transformer architecture. Actually, we'll discuss a bit about the transformer architecture in this video later. Okay. So once the input is passed through the transformers architecture, it will define and determine the desired output for the users. And it is passes through the hidden layers. These are the hidden layers in a transformer layer architecture. So once that is passing through the transformer architecture itself, it is start the training process in a feed forward layer and back propagations. So it will internally itself, it is evaluating the input, and it's trying to generate the output to the user. And finally, the inference. So once the model is trained, it can be used to generate the text, translate languages, and answer questions which are requested by the user. When the user provides a prompt, the model uses its learned knowledge to generate a relevant and coherent responses. This is how large language models works internally. Okay. So explore about Google Gemini models and OpenAI's available versions. So in this, Google Gemini has different versions, that is 1.5 Flash, 1.5 Pro, and these are the available. Actually, this 2.0 Flash is recently is released on 11th of December 2024. It's a latest version. So in this latest version, it's in a experimental mode. Currently, we are available Google Gemini Flash 1.5 Pro and 1.0 Pro. These are the available large language models from the Google Gemini. So in this advanced Google 1.5 Pro, there are some vast number of features, and the tokens limitations is also very high. You just try to go through these all models that are available as Google Gemini API, Docs, models, and Gemini. And coming to this OpenAI's models, currently it's a free version, Google 4.0 mini, and these are the available LLM model and its versions from OpenAI side. Okay. So coming back to this transformer models. So why transformer models are important and are playing a key role in large language models? Most of the large language models currently, like a OpenAI's ChatGPT or any GPT-4, Meta's Llama, or Google Bet, Megatron's, NVIDIA's Megatron, so Grok and Google Gemini, all are utilizing the transformer architectures. That's why we are discussing about transformer architecture here. So in transformer architecture, we have a 7 different layers. These are the available layers. That's what that we are going to discuss about this. So we'll just go through the picture. This is a transformer architecture insider, and it contains a 2 factors, that is encoders and decoders. Encoders take the input and it analyzes internally and passes to the decoder. It helps to produce the output to the user. This is how look like the transformer architecture. Okay. So in this first layer, tokenization, when a user provides input as a prompt, the LLM split the text into smaller pieces. That's this is how looks like tokens. This is how looks like the text is split into tokens. So the tokens can be word or subwords or even a characters also, sometimes depending on the model. Tokens are splitting into smaller units so that LLM can handle complex language more flexible and efficiently. In the next layer, the self-attention mechanism that allows each token to look at other tokens in a sentence to understand the input context and reduce the redundancy. That each token is mapped to the unique IDs using the vocabularies. And then it passes through the embedded layers. The unique number IDs are passes through the embedding layers, which converts into a dense and lower dimensional vectors. Here in lower dimensional vectors, we have a three elements, that is query, key, and value. We will take the new video on this query, key, and values to understand more, and it will be passed through the ways to interpret the given context. And it passes through encodes and a semantic relationship and meaning of the individual words based on what it has learned during the training process. So in multi-head attention mechanism, so the given context passes through the internal input hidden layers to generate the desired output, that is multi-head attention models. So in this multi-head attention model, sentences are simultaneously capturing the complex relation and context between word by processing each word and its relation to the others. The model computes attention weights to determine which part of input sequence are most relevant to the currently analyzing token to produce the next token. That means words. Okay. And in positional encoding model that enables to recognize the order of tokens, that means sequential order of the tokens, what should provide to the next word. And by addressing the encoding tokens position within the sequences. In another way, positional encoding helps LLMs to understand the sentence structure and relationship between the sentences. And feed forward layer. This is also one of the important feed layer in transformer architecture. So each token representation is passed through these feed forward neural networks for further transformations. This helps model to refine its understanding of tokens context to create a final output presentations. So in this final layer, the layer stacking and in-depth, the critical component of transformer model like GPT and other LLM models, which has a multi-layer stacked on top of each of to create the deep model. In this, each layer refines and processing the information to receive, allowing the model to understand the complex relationship between the patterns and the norms in the given input data provided by the users. Okay. So this is how the transformer architecture has a different layers. When a user provides prompt to the LLM, that given prompt is passed through all these layers to generate a desired output to the users. So these are the currently major large language models which are utilizing the transformer architecture. Actually, we have another lot of more large language models are also for utilizing the transformer architectures. Okay. And you can find more large language models in Hugging Face and llmmodels.org and other platforms as well. So we'll just go through the what are the capabilities of large language models. So see, these many capabilities are done by the large language models. So it's processing the natural language, understanding, text generation, and understanding the given input, that data summarizing to the from the documents, and the translation and multilingual support. This multilingual support means you can generate or translate from text from English to other languages, from other languages to English as well, as you know already. If you are using the Google translators. Okay, text summarization and question and answering, sentiment and emotional analysis. This is happening on the social media or reviews. By analyzing the reviews provided by the customers to the client. So based on that, you will understand like a positive or negative or neutral situations. Okay. And it can large language models are large language models like Phi 2 by Microsoft. It can generate code and debugging the code as well. Even including the Copilot, Microsoft Copilot also has a code generation and debugging capabilities, and other code generation capability large language models also available in open source and paid. And it can generate a creative content, poems, stories, and all these, and knowledge retrieval, personalized recommendations, data analysis and insights and reports generation, and dialogue management. Dialogue management means it's a conversational flow to maintain the user, to maintain and engage the users. And more other features like nowadays, multimodal large language models. Actually, these are multimodal large language models. Google's Gemini, OpenAI's ChatGPT, and Microsoft's Copilot, and NVIDIA, and Midjourney. These are all multimodal architecture, multimodal large language models. Yeah. Thank you, guys. Thank you for watching this video on large language models. Have a great day.